Okay, in this video, I want to go over real quick, looking at how pneumatic logic works in a circuit. All right, and this is going to be a basic introduction to it. And maybe I'll make some videos if I get a chance later to going a little more depth, but we're going to cover some of the most common pneumatic logical circuits. Now, these are not used a ton out there anymore in industry. There are still machines that absolutely will use pneumatic logic. It is, though, oftentimes taught in most tech colleges at some level. Understanding logic is really important for any industrial electrician. And so anytime you have a opportunity to learn logic, if you're a maintenance guy or an electrician, it's really important because the more exposure you have to it, the better. All right, so I have a basic circuit right here in pneumatics, and I basically set this up on a couple of different levels. So down here is our power, or our power level, where the power comes in. Okay, now you notice that I have a individual pneumatic power source at each place here. Then we have in this box right here the signal level. That's where the signals are going to be coming in from the real world. This level right here, this is what we call the process level, sometimes referred to as the logic level. Then the next layer is going to be the control layer, and this is going to be the things that are tied directly to the actuators. Sometimes there will be flow controls in between here, which is great. We don't in this example. And then here we have our actuator level. So you can see that what we want is, when we're drawing pneumatic circuits up, we want there to be a logical layering system to it. So this is really important just as a general rule when you're asked to draw these up. So let's walk through this one. So over here I have what is called a shuttle valve, sometimes called an OR gate. And if you've had like PLCs or digital fundamentals, you'll know what an OR gate is. But we refer to this in the pneumatics world as a shuttle valve. And how this works is I can push either this push button here or this push button here to send a signal to activate the control valve. In this case, this is a 5-2 directional control valve, and it's air actuated. There are a couple of different symbols out there for air actuation, and this is the one that I chose to use in this one. There are like 2 or 3 other ones that are somewhat common. So with the OR gate, how this works, or the shuttle valve, how it works is I can push this one, or both, and that will send a signal over to here and shift the directional control valve, extending the cylinder. Now on this circuit here, I have what's called an AND gate. Okay, now an AND gate, there's a couple different ways to set these up. Sometimes you will actually use an AND valve like this right here, or you can actually change it up and use the way you actually install the switches, which I'll show you here in a minute. So on an AND gate, what has to happen is you have to push this one and this one to send a signal out to activate this side of the directional control valve, retracting the cylinder. So there's enough of me walking you through it. Let's go ahead and take a look. So I'm going to activate this push button. That extends the cylinder out. Now notice this went red. This is sometimes referred to as a specialty check valve. That shifted up over to here and shifted the directional control valve into its position that allows the cylinder to extend. Now to get this back, what I have to do is I have to activate both of these at the same time. So if I push this one, the air comes through and gets blocked. If I push this one, air comes through, gets blocked here. So I have to push them both at the same time. So I'll lock this one into position, and then I'll push this one here. Air flows through, comes up, moves the directional control valve into a position that allows it to retract. Okay, and this is again just the very basics. And if that's all you were looking for in this video, awesome. I'm going to go ahead and have a little bit of a different conversation and make this a little bit more advanced so you can kind of see some of the things that you can do with pneumatic logic. So one thing real quick, you'll notice that all my pilot lines are dashed. All pilot lines need to be dashed. And if you ever have a question about what is a pilot line, it's something where you're using the pressure to control a signal, not an actuator. All right, so let me show you a couple cool things you can do here. So let's say I don't want to use an AND gate. What I can do, or an AND valve, I can bring this over here and line this up at least, and this is actually how you would wire it as well. I'm going to hook this into here, and I don't like extra 90 degrees in my diagrams, so make this a pilot line. So I always try to shift things over and make it look real nice. Bring this over, make this a pilot line, and here we go. Now I've also created an AND logic circuit. Notice I'm not using this anymore, so I can now activate this and this. There are advantages sometimes to having an AND gate, okay, or an AND valve. And that has to do with where you're physically positioning them on the machine. But since we're doing this at the schematic level, I'll keep everything kind of just how this is drawn up, understanding that schematics don't represent where things are physically placed in the real world. And now you can also do some combination logic. And let me show you what that means. So I'm going to create another push button here, and I'm going to drop this line into here, bring this line up over to here, and I'm going to bring from my AND valve, from the output of my shuttle. Change these to pilot lines. All right, now I have a combination logic where I have to have this one activated and either of these. So this can be operated here or here as long as this one is activated. And this circuit over here has actually remained exactly the same. So I can come over here, I activate this, nothing happens. So I come here, I place this in the position to allow air to come up to here. I activate this one. Now you can see the cylinder is extended. Now to retract it, I need to activate this one and this one to get it to retract. And when it comes to pneumatic logic, although it's not used all the time, it is just as flexible as a digital circuit and a PLC circuit. And so these all can be done in motor control circuits, these type of logic circuits. Pneumatics are no different. So when you look at a motor control circuit, a PLC circuit, a digital logic circuit, all of those types of things can be done in a pneumatic circuit, and sometimes have to be, especially if you're in like clean rooms where you can't have any electrical signals. There are a lot of old machines that at one point were running off of pneumatic logic. And if those machines haven't broken, and let's say they perform a function that is critical to an operation, you may still run into things like this. And so it's important to start off the conversation with pneumatic logic, I think. And then later on, when you get into the electrical control of electro-pneumatics, it'll help you to understand what's happening. All right. So anyway, I hope this video kind of just gave you a quick introduction to some pneumatic logic. And if you have any questions or comments, please leave them down below. And if you would, hit that like and subscribe button. Thank you so much.